Let's say that is 2024, which for the record is 5 years from now. Let's say that we reached that year and things have happened. The first crowd-funded mission to space, put a lander on the moon, and now we have a live stream of the Earth rising. Pretty nice. Closer to home, the United Kingdom is still trying to quit the Eurovision Song Contest or whatever it is that they try. And for developers, we have the tooling to be able to build apps that, with the same application, are going to work in pretty much all the range of devices, but especially in different user agent types. So they work for auditory user agents, for visual user agents. And these applications run fast. They are performant on every platform. And in the visual platforms, they have nice animations, and they have high-quality design. Sounds like a great vision, a pretty big vision. I believe it's possible. That's why I'm talking about it. But I believe that we have to do some things to reach there. And this is what I'm going to talk about. So this presentation will have two endings, let's say. Part of this presentation, a big part of it, is about the story of what we actually did at Klarna and what we actually did to achieve applications that will work in the same manner in the web and in native, and with our ambition, even maybe into other platforms. But also the things that we figured out as a team, that are maybe not enough in the current foundations of the web platform and application platforms that are preventing us from really going full in with universal applications. And that's going to be the second conclusion, which hopefully will be fixed by 2024. So we start with the need to build a universal application. Oh, the mouse cursor is there. There you go. The need to build a universal application. We had to build, about 2 years ago, we started at Klarna building an application that was supposed to look and behave the same way in React Native and in web. Now, we knew exactly how to do this in web. We had experience as front-end developers. We had a small team of front-end developers. And we knew essentially how to do it with HTML. And we were starting with React at that time. By the way, the code I'm going to show here is just a representation. Think about it as kind of detailed pseudocode. I'm not going to actually show you how to solve these problems in the code itself, because that would take simply too much code. But the learnings are still there. So I'm going to use this code as a representation. Don't expect it to actually show what is in the left. So we knew how to do it in the web, and we could do it. But we didn't know exactly how to approach the native applications. By this point, React Native was becoming popular, so we take it into consideration, especially because we didn't have any native developers in staff. I mean, Swift developers or like Java developers for Android. So we couldn't approach it without hiring a lot of new people. Instead, we went from React Native. And we really bought into this idea that you can learn once how to do an application and then write for everywhere. We really like this idea. This way you can keep hiring JavaScript developers, really, which we are many. And you can develop for this new platform without having to pay the overhead of a new programming language and environment. But as we went forward with implementing this, in the first prototypes, we started to notice that even though it was different code and different actual components, the structure of the application for web and the application for native, which were initially separate, was starting to look pretty much the same. I mean, it was supposed to look the same and behave the same, and the state management for it was going to be the same sort of Redux state, and it was going to communicate with the backend with HTTP calls with exactly the same backends. The only difference was in the UI implementation, the actual UI components, and those, even though they were different, share the same structure. This was very tantalizing. Could we go one step further? Could we write once and run anywhere? Not just learn once, just write only one application. We decided to go for it. The first step in abstracting this away is to try to make components that will work the same way in both platforms. And we started with the wrapper components. The simpler one, the view that you place around your entire application. In the case of web, being a div, in the case of native, being what is called a view. I'm not going to assume that you know React Native. So in native, you have something called a view that is very similar in behavior to a div. And we started to think about what this view component was doing. And there is an old joke that says that React should really have been called rect. Because what allows you to do is to draw rectangles on the screen. This is what you do with it. It's not a very particularly good joke, but it has some truth to it. Because with a view, you can define an area on the screen. You can paint it so that it has a background, so it's a rectangular, painted rectangle. You can put rectangles inside it, and you can place it next to other rectangles as part of a layout. So we thought this is pretty much a div plus flexbox, because the view in React Native automatically has the flexbox layout system. This is a decision that the React Native team did when they were implementing what layout strategy they are going to have to it. It's actually not just flexbox. That's where there is an asterisk in it. You can also do absolute positioning. This is going to be important later. Now, this is not an accident. This is not an accident at all. The React Native team wanted to have adopters from the web platform, from the people doing web development, so they opted for familiarity. They went for an API that would be familiar to developers from web. And another thing to notice on this is that this API is a little bit leaner and more focused on the web API. So you have a concept of a view which will draw a rectangle, and that's pretty much the only thing that can do. And this view only has one layout system. You don't have CSS grid, you don't have float. You might miss those things, for sure. You might miss them. But it's reducing scope, so it's easier to predict what's going to happen with it. What I'm trying to say is that the React team took some learnings from the web API, which you might or might not agree with, but they try to operate on top of those learnings. So the way we implement this universal component is that we place it in a folder, and we have two files representing the web version and the native version. You can do this with the build system for React Native, so that .native.jsx or JS will be picked up by this build system and put for the native targets for iOS and Android, and the .web.js or JSX will be used for the web when building for the web. If you are importing this container then, which you can import back into our form, it will be correctly built into either system at build time, but when you're consuming it and writing your app, you don't have to write two versions of it. You can write only one. So we placed it back in, and it just worked, which is great. It was very encouraging. We decided to go forward. The next thing to try is this login headline. Now there is an important difference between web and native, a crack that is going to start to show. In web, the element for this is the H2. So it's a heading of level 2. It's not just a text component. It has semantic information embedded into it. This semantic information is not there in the text. Sorry, in the native text. So what we had to do there is that we had to no, sorry, that's just that. Another thing to notice, though, is that we have more text present in the screen, in the form of the placeholder and in the form of the send text in the button. We don't usually think about this as text in the same way that we think about headings and paragraphs as text, because they are hidden as properties or it's inside the button, which we don't consider a text component. But this is also going to come back to bite us. So we start with the heading, and we do this abstraction by creating another component that will compile to text in native and to span in web. Span being the good approximation semantically to text. You just place text there, and it will float in line with the rest. We put this back. It works. Great. And it's at this point that the designers come into the room and tell us that we need to add another feature into this login form. In particular, when you press the send button, if the internet connection was down, they want to show some sort of pop-up appearing from the top. The good news is that at this point, we can build such pop-up with just universal components. We can put a container, we can put some font, and it will do. Say, there is a lot of style missing in there. As I said, this is pseudocode. But the point is that you can, at this point, already write universal pop-up. So we put it in there, we show it to the designers, they really like it, so we can keep moving, go for more universalization. We tackle the input component next. The input component is also very similar. We simply put the text input for native and the input for web. with some resets for the web. This is something that keeps popping up. So the web has user agent style sheets that by default will affect your components. Native got rid of those. This is one of the linear things about native. So you need to actually reset your input to match the style of the text input. But on top of that, we had this mismatch in the way that we configure our input fields. So in web, to have an input field of type password, we call it type password. But in native, we call it secure. We add a secure text entry Boolean to it. Which of these approaches is the most correct? It's an open question. In my opinion, it's not a different type, the password. It's just a different way of showing it. So I think the React Native way is a bit more nuanced. It makes more sense. It goes back to this impression that I have that the APIs are linear and more focused. But the point here really is that we need to sort it out. We need to bridge this API so our universal API will solve the conflict between the two. In our case, we usually choose the native APIs because of this focusing. And in this case, we can use that Boolean in the website to choose between the types. We place this back into the form, and we're making a lot of progress here. Field is already universalized. The only one missing is button. Again, at this point, the designers come back and say, hey, wait, this box that you put in the top shouldn't just appear there. It should be animated down from the top, like a push notification. OK, that's fair enough. Let's just add a transition. We can transition the top property. I mean, it was position absolute. So we can transition it in, and it will look nice. Except that there are no transitions in native. Like, there is no such concept. CSS spoils us to think that a lot of things that are easy to do in CSS are actually easy in any UI. And that's not necessarily the case. There is hope, though, because you can use some libraries that will work universally. React Motion, React Spring, there are many others. The point here is not to illustrate exactly how to do that, but is to illustrate an interesting fact that appears when you try to use a JavaScript motion library, which is that the property that you're animating, the top property in this case, needs to be a specific pixel size. You cannot do it with 100% because there is no such concept in native. You're actually animating a certain size. And now, because of that, we have a constant with the pixel height of our box as part of our component. OK, this works, though. The animation appears there. The designers are happy. So we can move on to our button. We go to the button. We take a look at it. And we see that in native, there is something called touchable. Now, touchable in native is an interesting concept. It doesn't have its own layout. It doesn't have its own design. It doesn't have text properties. It doesn't have background properties. It only provides a handler for pointer events. That's the only thing it does. The equivalent in web could be a button without any styling, really. So we initially go for that, and we put some text into it. And the problem is you cannot just put text inside the touchable. See, the components in React Native are focused enough that if you want to place text, you need to put it inside a text component. Now we are bringing abstractions back from native into web. And when we build this touch, we need to also build a button on top that will also have a container, will also have a font. And this will build a layout more akin to what we're using in web. See how now we need to reuse that font component, or the text that was inside the button. We need to treat it as proper text. So we replaced the button, and everything is working. And by this point, we actually managed to make this particular login screen universal. It works everywhere, which is really, really nice, except that we shouldn't forget about alert box. Alert box comes up when, in localization, fittingly for the previous talk, and the QA finds that the text in German does not fit in the same space. We asked the designers how to solve this, and predictably, they suggest that we fold it into multiple lines. The problem, though, is that by this point, we have a constant with a fixed height for this box in the code. And when this box is hidden with the top property to the app, it's actually partially showing up in the German translation. How exactly do we fix this? Do we change this box height to something dynamic? What could that dynamic thing be? Do we add a German height to the box? No. That would be a terrible idea. So what we do is go back to the designers and tell them we are really sorry. We're not going to do this. It will just appear or have opacity transition. How about that? So we finish our login form. We ignore this particular small fact that the motions didn't work and continue our universalization quest throughout the rest of the application. By this point, we really have a template on how to do universalization. We're going to have a universal something that compiles to a web something with some style resets typically, and to a native something with some defaults. And we keep going with universal scrollable views, which is how you define them in React Native for something that scrolls, for SVG elements, so you can have surfaces and path and everything, and you can keep going and going and going and build universal everything. This is, though, something that is not exactly new. Almost immediately after React Native was originally launched, this library called React Native Web appeared, which aimed at using the React Native concepts in web, so you could write the application only once. After that, there was this React Primitives library, which is also really, really interesting, had a more nuanced view, trying to abstract even from React Native. And more recently, there is React Native DOM. These are really good libraries. There's no problem with them. So all of this sounds great. What's the catch? Why aren't we all doing universal applications already? At this point, I'm going to make a quick interlude and tell us essentially why did I go so deep into this. For the most part, this is where I should have had to stop, and the people in my team will have had to stop. But I happen to work as part of the design system team at Klarna. Now, we are a mixed team. We are developers and designers in the same team. And we work to optimize the UI so that for everybody in the company. Now, design system has become a bit of a buzzword, so you might know what I'm talking about. But in case you don't, we provide assets for design and development for everybody to be able to build UIs in the company. These are React and React Native assets in NPM, and they are symbols in Sketch that designers can reuse and automatically update. Now, as we went forward with this and started to finding out all the limitations, we started to find out that something strange was going on that we never thought about before. Let's think about how we implemented this universal font, container, and touch components. We implemented them as div, span, and button, respectively, in web. And we did this because they matched the behavior, expected behavior, and semantics. But we didn't have to. Think about the font component. It has a span as a web implementation, but you can easily turn it into a div with display inline, and it could do the same thing. If you're worried, you can also do this with a button even. You can literally make a button, no longer take any keyword interaction by setting the tab index to -1, and setting the area role to heading. It will even be accessible. It's crazy. You can also do this the other way around with the button. The button captures the on-press, but a div would also do that. And then you can set the tab index to 0, so it captures keyboard focus. And you set the role to button, and voila, it works even in screen readers. Isn't this a bit strange? Why can you do this? You cannot do this in native, that's for sure. You cannot turn a view into a text just by styling it. Another odd thing had to do with the measuring of this text up here. So this text, we didn't know what the height was going to be. Isn't that also strange? So what this led us to kind of realize is that in the web, we're kind of used to this, but styling and events seem to be fit as an afterthought. And that's the question. Are they an afterthought? Well, let's talk a bit about the DOM rendering engine. Now, rendering engine is a keyword usually associated with games. Unreal game rendering engine, the source rendering engine. We don't really think it's a DOM in that way. But it is a rendering engine. And it is very peculiar at that. See, if you put a lot of text into most rendering engines in existence, including Canvas and SVG, which are also in the web, this is not what the text could do. It will not fold into multiple lines. Instead, it will do this. So it's strange that the web is folding it. not only it folds it, it adds a virtual box around it, so that if you put more content, it will appear below and not on top of it, overlapping. This is also strange. I mean, it's really good. The web is responsive by default, and it would behave very well for text, but why? On top of that, if you put more content, a scroll bar will appear, but only vertically. It will not do it sideways unless you put a gigantic image or something like that. OK. And when we think about styling, and we think about building complex applications that can do custom layouts that our designers dream in their wildest dreams, the only tool we have to do that is CSS, which is only just tweaking this. Why is the DOM engine working this way? So to answer that, we need to go all the way back to 1990 to the European Organization for Nuclear Research, CERN, which now hosts the Large Hadron Collider. The point of this is to illustrate how different the environment of the web was when it was created towards what we actually do with it right now. And the purpose of it, which was actually sharing scientific publications. Scientific publications, since writing in general, since the beginning of writing, has a visual structure embedded into it that was converted into a code structure. That code structure is optimized for documents. This is modern HTML, but still, you can see the reminiscence in there, the superindex notation, the address notation. We don't have motion primitives on the web, but we have nuanced document markup syntax. Another thing that scientific papers have is citations, reference to other scientific papers. Those were turned into addresses and links in the hypertext. Again, we all know this, but it's worth remembering that this is what it was optimized for. The flow that it was inspired on was essentially going to a paper, reading it, finishing it, going to a next paper. This was transformed into a digital experience in which you read a document, you click a link, you find another document. The unit of interaction in the web is navigating away. There is not supposed to be nuanced interactions within the page. It was not designed for that. So that brings us to the problem of what an app even is. Is an app a document or is it a game? As a document, it could be structured, and the content could be readable in many platforms. As a game, it's animated and continuous. A game requires dexterity as well. And a document is a passive experience that you don't interact with except for its scrolling until you navigate a game away, while a game is something that you're interacting with all the time. It might be tempting to think that an app is a game. It might be very, very tempting to do that. But just this week, because Domino's did that, they got sued, their website, their application was no longer accessible. You don't have to sacrifice one thing for the other. You can do both. I'm a have your cake and eat it too kind of person. But you need to be mindful of this. So let me finish right. Oh, I'm really running out of time. OK, so let's see what is the main impediment towards doing this today in the web. The main impediment towards having powerful applications like in the web is actually text measuring. See, this thing prevented us from being able to do the motion properly. And there is a way to measure that, but you have to do it after you render, so that you draw the box, you measure it afterwards, then you re-render it, then you remeasure it, and then you render again, and so on and so on. Maybe it will find a fixed point in which it will stop rendering again and again, but you're not sure of that. And for comparison, this is what it looks, a function in which you just render something, and then it gets output. And this is what it looks like when you have a function that fits into itself. This is not an exaggeration. This is literally how it looks in math. So let me think about how I do this, because I'm running super out of time. I'm going to skip one section. Yes, let's go back to 2024. What we should have solved for being able to do this is having fully deterministic rendering, rendering that is completely under our control. We can do that by implementing better text rendering algorithms on the web. This paper from 1980 has been available, well, it has been out for 40 years. And the web does not have this rendering engine yet. So what I would suggest that we do is that we do this in userland. There is precedent to this. jQuery existed before query selector, Flash before SVG, and ASM.js before WASM. The W2C will catch up. Thank you.